strange signals detected from Antarctic ice seem to defy laws of physics. Scientists are searching for an answer. Scientists are trying to solve a decade-long mystery by determining the identity of anomalous signals detected from below ice in Antarctica. The strange radio waves emerged during a search for another unusual phenomenon, high-energy cosmic particles known as neutrinos. Arriving at Earth from the far reaches of the cosmos, neutrinos are often called ghostly because they are extremely volatile or vaporous and can go through any kind of matter without changing. Over the past decade, researchers have conducted multiple experiments using vast expanses of water and ice that are designed to search for neutrinos, which could shed light on mysterious cosmic rays, the most highly energetic particles in the universe. One of these projects was NASA's Antarctic Impulsive Transient Antenna, or ANITA, experiment, which flew balloons carrying instruments above Antarctica between 2006 and 2016. It was during this hunt that ANITA picked up anomalous radio waves that didn't seem to be neutrinos. The signals came from below the horizon, suggesting they had passed through thousands of miles of rock before reaching the detector. But the radio waves should have been absorbed by the rock. The ANITA team believed these anomalous signals could not be explained by the current understanding of particle physics. Follow-up observations and analyses with other instruments, including one recently conducted by the Pierre Auger Observatory in Argentina, have not been able to find the same signals. The results of the Pierre Auger collaboration were published in the journal Physical Review Letters in March. The origin of the anomalous signals remains unclear, said study co-author Stephanie Wissel, associate professor of physics, astronomy, and astrophysics at the Pennsylvania State University. Our new study indicates that such signals have not been seen by an experiment, like the Pierre Auger Observatory, Wissel said. So, it does not indicate that there is new physics, but rather more information to add to the story. Larger, more sensitive detectors may be able to solve the mystery, or ultimately prove whether the anomalous signals were a fluke, while continuing the search for enigmatic neutrinos and their sources. Scientists say the search for neutrinos detecting neutrinos on Earth allows researchers to trace them back to their sources, which scientists believe are primarily cosmic rays that strike our planet's atmosphere. The most highly energetic particles in the universe, cosmic rays, are made up mostly of protons or atomic nuclei, and they are unleashed across the universe because whatever produces them is such a powerful particle accelerator that it dwarfs the capabilities of the Large Hadron Collider. Neutrinos could help astronomers better understand cosmic rays and what launches them across the cosmos. But neutrinos are difficult to find because they have almost no mass and can pass through the most extreme environments, like stars and entire galaxies, unchanged. They do, however, interact with water and ice. ANITA was designed to search for the highest energy neutrinos in the universe at higher energies than have yet been detected, said Justin Vandenbroek, an associate professor of physics at the University of Wisconsin-Madison. The experiment's radio antennae search for a short pulse of radio waves produced when a neutrino collides with an atom in the Antarctic ice, leading to a shower of lower energy particles, he said. During its flights, ANITA found high-energy fountains of particles coming from the ice, a kind of upside-down shower of cosmic rays. The detector is also sensitive to ultra-high-energy cosmic rays that rain down on Earth and create a radio burst that acts like a flashlight beam of radio waves. When ANITA watches a cosmic ray, the flashlight beam is really a burst of radio waves 1/billionth of a second long that can be mapped like a wave to show how it reflects off the ice, an anomaly in the data twice in their data from ANITA flights. The experiment's original team spotted signals coming up through the ice at a much sharper angle than ever predicted by any models, making it impossible to trace the signals to their original sources. The radio waves that we detected nearly a decade ago were at really steep angles, like 30 degrees below the surface of the ice, Wissel said. Neutrinos can travel through a lot of matter, but not all the way through the Earth, Vandenbroek said. They are expected to arrive from slightly below the horizon, where there is not much Earth for them to be absorbed, he wrote in an email. The ANITA anomalous events are intriguing because they appear to come from well below the horizon, so the neutrinos would have to travel through much of the Earth. This is not possible according to the standard model of particle physics, the peer-auger collaboration, which includes hundreds of scientists around the world, analyzed more than a decade's worth of data to try to understand the anomalous signals detected by ANITA. The team also used their observatory to try to find the same signals. The Auger Observatory is a hybrid detector that uses two methods to find and study cosmic rays. One method relies on finding high-energy particles as they interact with water in tanks on Earth's surface, and the other tracks potential interactions with ultraviolet light high in our planet's atmosphere. The Auger Observatory uses a very different technique to observe ultra-high-energy cosmic ray air showers, using the secondary glow of charged particles as they traverse the atmosphere to determine the direction of the cosmic ray that initiated it, said Peter Gorham, a professor of physics at the University of Hawaii at Manoa. By using computer simulations of what such a shower of particles would look like if it had behaved like the ANITA anomalous events, they are able to generate a kind of template for similar events, and then search their data to see if anything like that appears. Gorham, who is not involved with the new research, designed the ANITA experiment and has conducted other research to understand more about the anomalous signals. While the Auger Observatory was designed to measure downward-going particle showers produced in the atmosphere by ultra-high-energy cosmic rays, the team redesigned their data analysis to search for upward-going air showers, Vandenbroek said. Vandenbroek did not work on the new study, but he peer-reviewed it prior to publication. Auger has an enormous collecting area for such events, larger than ANITA, he said. If the ANITA anomalous events are produced by any particle traveling through the Earth and then producing upward-going showers, then Auger should have detected many of them, and it did not. A separate follow-up study using the IceCube experiment, which has sensors embedded deep in the Antarctic ice, also searched for the anomalous signals. Because IceCube is very sensitive, if the ANITA anomalous events were neutrinos, then we would have detected them, wrote Vandenbroek, who served as co-lead of the IceCube Neutrino Sources Working Group between 2019 and 2022. It's an interesting problem because we still don't actually have an explanation for what those anomalies are, but what we do know is that they're most likely not representing neutrinos, Wissel said. Oddly enough, a different kind of neutrino, called a tau neutrino, is one hypothesis that some scientists have put forth as the cause of the anomalous signals. Tau neutrinos can regenerate. When they decay at high energies, they produce another tau neutrino, as well as a particle called a tau lepton, similar to an electron, but much heavier. But what makes the tau neutrino scenario very unlikely is the steepness of the angle connected to the signal, Wissel said. You expect all these tau neutrinos to be very, very close to the horizon, like maybe 1 to 5 degrees below the horizon, Wissel said. These are 30 degrees below the horizon. There's just too much material. They really would actually lose quite a bit of energy and not be detectable. The future of detection, at the end of the day, Gorham and the other scientists have no idea what the origin of the anomalous ANITA events are. So far, no interpretations match up with the signals, which is what keeps drawing scientists back to try to solve the mystery. The answer may be in sight, however. Wissel is also working on a new detector, the Payload for Ultra-High Energy Observations, or PUEO, that will fly over Antarctica for a month beginning in December. Larger and 10 times more sensitive than ANITA, PUEO could reveal more information on what is causing the anomalous signals detected by ANITA, Wissel said. Right now, it's one of these long-standing mysteries, Wissel said. I'm excited that when we fly PUEO, we'll have better sensitivity. In principle, we should be able to better understand these anomalies, which will go a long way to understanding our backgrounds and ultimately detecting neutrinos in the future. Gorham said that PUEO, an acronym that references the Hawaiian owl, should have the sensitivity to capture many anomalous signals and help scientists find an answer. Sometimes you just have to go back to the drawing board and really figure out what these things are, Whistle said. The most likely scenario is that it's some mundane physics that can be explained, but we're sort of knocking on all the doors to try to figure out what those are.